And if you look at our whole history of snowmelt at our stream gauge, which is really short, from 2006 through last year, you'll see that the pattern changes every year, which of course reflects weather differences year to year. We've had dust in the snowpack during all 4 of these years, but the coming and going of clean snow, of fresh snow, and those ephemeral changes in snow albedo are still in charge of snowmelt, even with dust present. And there's a major difference, particularly between 2006, which is the light blue line, which shows the stream flow surging, briefly pausing here, and then surging to a peak, and then steadily dropping, all in one basic climbing and descending trace. And if you recall, in spring of 2006, snowmelt started about a month early and was over about a month early, all over the state. And water managers were just scrambling and very perplexed. They had no idea really why this was happening. But we were able that spring and that summer really, to come to them and talk about this single dust event way back here in February 15th, that essentially emerged all over the state, just about here, and then stayed at the surface because the spring just completely dried up. No new snow at all. And that just forced snowmelt into that early and rapid early timing and high rate to the point of a peak about a month early, and then really rapid drop-off. If you look at compare that to the dark blue line, you see we had just as much dust in the snowpack in the dark blue year, which is hard to see, it's 2007. But we went through these on again, off again, on, off, on, off, on, off, on, off, on, all spring because of just this kind of routine cycle of dust emerging, surging snowmelt, and then shutting it off with new snow. And then dust would reemerge and get rolling again, and then it would get another storm and shut it down. So albedo was going up, down, or down, up, all spring long, and that very nicely prolonged snowmelt. And it was a good thing because that year, as you may remember, a lot of watersheds had almost 200% of snowpack. And had we had the pattern of dust emerging and staying at the surface in 2007, we no doubt would have seen really extensive flooding. There was minor flooding even with this pattern in the Animas River drainage and in the Yampa. So this year we have a somewhat different potential, and I'll talk about it in a second. Now, this student at the Snow Optics Lab under Tom Painter has done this analysis, which is these charts represent 2005, 6, and 7, and then I'll show you 2008 and 9. And what she's done is evaluate the impact of the observed dust on snowmelt timing and rates, and then modeled how snowmelt would have occurred given the same weather, exactly the same weather conditions, with no dust, in the absence of any dust, and calculated the difference in those dates of snow all gone. So, again in 2006, just go right to that. The differential in our study area between the actual observed date of snow all gone and what that date might have been in the absence of any dust or any dust radiative forcing was 31 days. And the year before it was 28 days, the year before it was 30 days. Last year it was 50 days advance in the date of snow all gone in our basin. And the year before, 08, was 26 days. Then she looked at, well, if these typical projections for global change of adding +2, maybe +4, maybe even more, but let's just start with +2 and +4 degrees Celsius to these systems, what would the effects of that kind of air temperature change be on these effects? So she added to the dust effect +2 degrees C to our actual measured weather data throughout the whole period of snowmelt. And then she added +4. Those are the yellow and orange traces here. And those are not huge effects relative to the change between dust and no dust. They're minor. Then she also did the same with no dust scenario, adding +2 and +4 degrees. So in the absence of any dust, adding 2 degrees C to climate in this system would have advanced snowmelt 6 days. And 2 degrees C is kind of the consensus for the effects on desert southwest region. +4 is pretty high end. There aren't that many models that project that kind of temperature increase. But she calculated +4, that's only 13 days. So the point here is really that as important as those global change effects and warming effects might be on lots of other elements of the mountain system, vegetation and everything else, you know, the future is kind of now in terms of effects on snowmelt timing and rates, and it's being produced by this dust effect. This is a dramatic effect that really is eclipsing even the potential effects of these of warming. And the caveat, of course, is that this is modeling. We're modeling clean snow. We're modeling the effects of adding temperature to the system, adding more sensible heat. And you all know, I'm sure, you know, the uncertainties associated with that kind of modeling. They're not trivial, they're not non-existent, but we do use the best available snowmelt model to do this work with. The other effect of losing snow on the system is shown here. This is 2005. These are actual measured increments of extra energy being absorbed by the snow because of dust until the date of snow all gone, here, which of course opens up the ground for radiative inputs. And so all this energy up to these kind of values is getting added into the ground that much earlier. And that is a significant effect on particularly plant and soil processes.